Good morning, everyone. Okay, so till now we have covered some important topics, or we can say important chapters of class 12 till now. That means electromagnetism is already covered. So now we are moving towards class 11th, and the first topic that is very important is thermody. Thermody, almost I can say two or three questions can be asked from this chapter, from this thermo part. So we will start our session. Take your notebooks, take your pen, and try to write down everything that you want. Every punchline that is important, everything you should write. Okay, because a lot of things I will only speak and they are not mentioned on the screen. So just try to listen and try to catch them all. Okay. Give me a thumbs up if my voice is clear, everyone. So I will move further. Just give me a thumbs up. Okay, very good. I think someone has raised. Uh, okay, one up. Okay, so we will start. Let's move. Thermody. First of all, what is thermodynamic process? Listen to me very carefully. I will explain you one by one. What is this? First of all, there are three very important parameters, that is pressure, volume, temperature. These three parameters are generally known as thermodynamic variables. So any process by which we can change either any one of them or all of them is called thermodynamic process. One thing is clear, P, V, and T, that is pressure, volume, and temperature, are three very important parameters and known as thermodynamic variables. The variation in or the process by which we can change them is known as thermodynamic process. Now, what are the types of thermodynamic process? One is isobaric process. Isobaric, the name suggests the process in which pressure remains constant. This is mentioned on your screen. Pressure remains constant. Try to write it down. Another process is isochoric process. The process in which volume remains constant. That means you can change pressure and temperature, but volume will remain constant in isochoric process. Similarly, there is another process that is isothermal process. You can suggest, or you must have an idea what is isothermal. Iso means same, thermal means temperature. The process in which temperature remains constant and all other things varies. That is P and V may vary. Next is adiabatic process. The adiabatic process is something in which there is no heat transfer. There is no heat transfer between system and its surroundings. So no transfer of heat takes place. I think all these definitions are clear to you. There are four processes that we are going to study. After that, there might be a few variation, like there might be something like that cyclic process. There might be a process like reversible process. So these are another zone. The criteria on which we are dividing this is the only four type of processes are there. So we will explain these two processes later. So right now, moving further, everything is clear. Indicator diagram. This is again a very important thing. Most of the times you will see that there is a diagram all the time. There is a PV diagram, VT diagram. So what is this? Indicator diagram is representation of a process on either PV graph, pressure temperature graph, or volume temperature graph. You are not getting what I am saying. I am saying indicator diagram is what? Representation of a process on either pressure versus volume graph, pressure versus temperature graph, or volume versus temperature graph. This is a representation of what? Representation of thermodynamic process. Okay, some examples are here. That's mentioned here. You can read it out like this. You can see there is a graph between pressure and volume. One axis is pressure, another axis is volume. And there is a graph starting from A, ending at B. Now, what are the critical things that you should understand using this graph, or you can see from this graph is, if you see the process, the arrow indicates the direction of the process. Arrow is saying that process is starting at A and terminating at B. And if you can see at point A, the pressure is this one. And at point B, pressure is this one. Let's suppose this pressure is V1, this pressure is V2. Sorry, volume. My mistake, my bad. At point A, volume is V1 and point B, volume is V2. Can you see from this arrow that volume is increasing from V1 to V2? That means this indicates expansion. This indicates expansion. That means gas is expanded. You know the thermodynamic system that we generally use? The thermodynamic system is nothing but a cylindrical body like this, filled with some ideal gas, and there is a piston on it. This is called as piston. This friction can be moved up and down, and if the piston moves in upward direction, then gas expands, and if the piston moves in the downward direction, gas compresses. That's what I am saying, that in this diagram, you can see gas is expanding. You can identify this using this arrow sign. Now, in another graph, you can see, now again, you can see that gas is, the process is from A to B. You can judge it from this arrow. Now you can see that at this point and at this point, you are moving in this direction. So this is nothing but compression. This is nothing but compression. Is it clear now that how to use the indicator diagram? There might be a different type of indicator diagrams, like there is a PT diagram, there is a VT diagram. There are other diagram, other possibilities. So we will discuss them. So it's a short class, crash course. So you must have an idea about indicator diagram. Now moving further. What is this? This diagram represents thermodynamic system. Thermodynamic system. Which gas is filled in it? Ideal gas. Now your task is to write some points about ideal gas. What is the difference between real gas and ideal gas? You must write those points or search those points. What are the basic difference between these two? Ideal gas and real gas. You must find out. Okay. Now, what's more important or most important thing in this chapter is the calculation of work done in a thermodynamic process. In general, or basically, the work done of a gas is calculated by work done is equals to PdV, integration PdV. So don't worry about the integration thing. This is the simplest form of integration. You can easily do it if necessary. Otherwise, I will give you the formulas. Work done is equals to PdV. P is the pressure, dV is the change in volume, or this is the integration form. You can use the limit whenever required. Don't worry about that. Now, most general thing. Punchlines. Again, punchlines are always good to remember. First punchline is area under the PV curve gives the work done. Now listen to me. Let's suppose PV curve, you know, na? This is the indicator diagram. Let's suppose this is a PV curve. Remember everything. This is the most common question. Now let's suppose there is a process like that. Like that. There is a process AB. Now someone has asked you to calculate the work done. Someone means the examiner, the question paper setter, has asked you to calculate the work done, then what you should do is to calculate the area under this curve. This area you should calculate, and this area will give the work done. The statement is clear. Is the statement clear? The area under the PV curve, but the thing is, you must consider the area with the volume axis. If something is written like that, is drawn like that, this is P, this is V, and if there is a graph, something like that, and someone asked you to calculate the work done in this process, then there you must calculate the area with the volume axis, not with the pressure axis. If you can take this area, this is wrong. Which area you should consider? Area of the graph with the volume axis. So we are considering the area with the volume axis only. This area. Clear? Next thing that is very important again. The next punchline that I am writing, for expansion, you can identify the expansion, I think. For expansion, work done is positive. And for compression, work done is negative. If you have studied thermo D in your chemistry classes, then there might be a difference, and they must say that for expansion, work done is negative. So leave it to the chemistry classes and stick with this assumption in the physics classes. So try to remember that. Don't mix those things. There is a difference. For expansion, work done is positive. For compression, work done is negative. The another punchline that is mentioned here, work done in a cyclic process is given by the area enclosed by the cyclic process. This is again an important thing, the term that includes cyclic process. What is a cyclic process? Like this. For example, this is a PV diagram. P and V diagram. So what will be the cyclic process? A cyclic process is nothing but, for example, a process starts from point A, goes to point B, and again to point C, and then return to point A. This is the process. So you can say that process is starting at A and ending at A. That means it has covered a complete cycle. So such process which has initial and final state as the same are known as cyclic process. What is cyclic process? The process in which initial and final states are same. So for such situations, what will be the work done? The work done will be the area enclosed by the process. Is given by the area enclosed by the process. That means in this process, if you calculate work done, that work done will be area enclosed by the this area is the work done. So this is nothing but a triangle. You can calculate the area of the triangle very easily. That's the basic thing. Is it clear? Should I move further? Okay, everything is clear. Say at least one thing, yes or no, whatever you think. If you are not, if not everything is not clear, then you can ask me. Otherwise, I will move further. Okay, moving further. Now there are few processes that we have studied: isobaric, isoporic, some other processes, isothermal and adiabatic. So all of these processes, in different processes, there is different work done. So we will remember some formulas here, and you should remember these formulas because these are very important ones. Might be used in numericals directly. Okay. How many of you remember those formulas of work done? Okay. So for isobaric process, this is the representation of isobaric process. Can you see that? Isobaric means pressure remains constant. And in this process, you can see that whenever the volume is changing, but the pressure is constant at every point, like this point, this point, this point, everywhere pressure is constant. So work done is nothing but P delta V. P is the constant term here, delta V is the change in the volume. For example, if process starts from point A and ends at point B, so volume here is V1. Let's suppose here volume is V2. So work done can be written as P. Change in volume is nothing but V2 minus V1. Is it clear? P delta V. This is how you can write. One thing is common for expansion, work done is positive. For compression, work done is negative. Clear? Moving further. For isochoric process, whenever you talk about isochoric process, remember that work done in isochoric process is zero. Why the work done is zero? Because you know that work done is equals to integration PdV, where dV is what? Change in volume. And isochoric process says there is no change in volume. Volume remains constant. That means dV is zero. So work done is zero. And you should remember this. Isochoric process. The representation of isochoric process on a PV curve is like that. This one. One more thing that you can think of, that's again a very important thing. I will write it here. Generally, the ideal gas equation, I think many of you knows that ideal gas equation is what? PV is equals to nRT. Clear? So in this equation, or for isochoric process, you can see volume is constant. N and R are two constant things. N is number of moles, R is gas constant. So these two are also constant. So what can be concluded that P is proportional to T. This is for isochoric process, and again a very good punchline. P is proportional to T, or you can write at P1 over P2 is equals to T1 over T2. This is for isochoric process. There is no need to, if you can remember that, that's very simple thing. You can remember that P is proportional to T. Otherwise, you can get this. How I achieved this relation that PV is equals to nRT. Volume is constant in isochoric process. N and R are constant terms. These are gas constant and number of moles. So P is proportional to T. Clear? I think everything is clear in isochoric process till now. Moving further. Again, work done in isothermal process. Isothermal process is represented by this graph. The arrow represents expansion. At this point, pressure is P1 V1, and finally pressure is P2 V2. So P2 V2 and P1 V1, you should remember that these are the initial values. These are the final values. Okay. So work done is nothing but 2.303 nRT log V2 by V1, where V2 is what? Final volume. V1 is what? Initial value. And if you change this relation, you can get another form. This is in terms of volume, and this is in terms of pressure. I think till now everything is clear. This formula you should remember. This is the most important formula, because most of the questions generally come from this isothermal process. Clear? Should I move ahead? Okay. Okay. Very good. Write down this formula, because in numericals we will use that. At that time, don't stuck. So now work done in adiabatic process. Okay. One more thing to be remembered in isothermal process. If I talk about ideal gas equation again, that is PV is equals to nRT. Now, can you see that? Which term is constant in adiabatic process? You will say, sir, temperature is constant because process is adiabatic. And this N and R are always constant because number of moles and gas constant. So can you see that the relation will become P into V, and this whole RHS is constant. Is it clear now? P into V is equals to constant. So this is the punchline for the isothermal process. Now this PV equals to constant can be written as P1 V1 is equals to P2 V2, or if there is another point, you can write it as P3 V3. So this is what condition for isothermal process. Is it clear? Okay, I hope till now everything is clear. Remember the formula, remember this relation, or you can get this relation whenever required. Moving further for adiabatic. What is your homework in this isothermal process? Your homework in this isothermal process, conditions for isothermal process. You should study this from your notebook. It should be mentioned there. What are the necessary conditions for an isothermal process to take place? Clear? This is your homework. You should study it from your notebook or from your book, whatever you have. Okay. Work done in adiabatic process. Now, before mentioning this work done, there are few things that is to be remembered. One is there is a term mentioned here as gamma. This term is what? Gamma. So one thing you should know, what is gamma. Gamma is called as adiabatic constant. Write down, gamma is known as adiabatic constant. Adiabatic constant. Another thing, what is its value? Gamma is the ratio of Cp over Cv. Gamma is the ratio of Cp over Cv. Now, how many of you know that what is Cp and what is Cv? What is Cp and what is Cv? Anyone knows that? Say yes or no. Don't no, sir. Okay. Okay. Cp and Cv you don't know. Okay, let me explain. Cp. Yes, sir. Very good. May I say? Okay, very good. Cp is specific heat of gas at constant pressure, and Cv is the same thing but at constant volume. And the relation between them is Cp is greater than Cv and is equals to R. Cp minus Cv is equals to R. R is what? Mayer's constant. This is Mayer's equation, and R is what? Gas constant. And this equation is known as Mayer equation. Don't worry about that. नाम का क्या करना है? You just remember the relation Cp minus Cv equals to R. Gamma is equals to Cp by Cv. Now, what will be the value of gamma? Is it greater than 1 or less than 1? Is it greater than 1 or less than 1? You can see that Cp is greater than Cv. That means gamma is greater than 1. Gamma is greater than 1. Okay. The work done, the formula is nR T1 minus T2 over gamma minus 1, or P1 V1 minus P2 V2 over gamma minus 1. This relation you should remember. Another thing that is most important here, I will write it here. What is this? It follows some relation, that is P into V raised to the power gamma is equals to constant. This is the most important relation for adiabatic process. For isothermal process, the relation was PV is equals to constant. For adiabatic process, the relation is P into V raised to the power gamma is constant. This question is directly asked that for an adiabatic process, there might be 4 options, including this one. Then which option is correct? Then you can say this option is absolutely correct for adiabatic process. What is adiabatic process? Do you remember what is adiabatic process? The process in which no heat transfer takes place. Heat cannot be transferred between system and surrounding. Moving further. Now, one thing is sure, you have judged that till now that in the two graphs, look at the graph of adiabatic process and look at the graph of isothermal process. They are similar. They are almost similar. You can see that. Then there is a very famous question. What is the famous question? Comparison of slopes of isothermal and adiabatic process. There might be a graph like this one. There is a graph of P and V, and they are asking you identify which of them is isothermal process and which of them is adiabatic process. Question is clear. They are asking you which of these graphs is adiabatic and which of these graphs is isothermal. So one thing is to be remembered. First of all, tell me whether these two processes are expansion or compression. Write it quickly. Expansion or compression. Write it, write it. Expansion or compression. These two processes represents what? Expansion, expansion. Very good, may I say, very good. Okay, if expansion is there, so remember one thing. Whenever there is a graph of expansion and they are asking which is isothermal, then the graph which is above is isothermal and the graph which is below is adiabatic. You can remember this thing because this is a very common question. The explanation is quite large, so I am not going with that. The thing you can remember here in the crash course is this, that graph above the graph above is known as isothermal, the graph below is known as adiabatic, but this situation is for expansion only. This is for expansion. Now, again, if you can see, these two graphs are for compression, are for compression. So in this situation, the graph above is representing adiabatic process and the graph below is representing isothermal. So one thing to be remembered, expansion में isothermal above होता है. That thing you can remember. In expansion, isothermal is above adiabatic. Very important thing. Now, if you remember everything, how can you calculate the work done of a gas? How can you calculate the work done of a gas using area? Okay, so there is a concept question. Work done of a gas can be calculated by area under the PV curve. Okay, so read out the question. Very simple question. They are saying that two cylinders A and B of equal capacity are connected to each other via a stopcock. For example, this is a cylindrical body. This is another cylindrical body. And they are connected with each other via a valve. You can say a valve is there. A contains an ideal gas like this. This has an ideal gas. B is completely evacuated. There is nothing in B. This is A, this is B. The entire system is thermally insulated. Thermally insulated means no heat can transfer. The stopcock is suddenly opened. The process is. This is a very simple question. The previous year question is, however, the gas is suddenly, the switch is, or the stopcock is suddenly opened, then what will happen? The gas will transfer to this as well. And in the complete process, no heat can be transferred because this system is insulated, thermally insulated. That means no heat can be transferred. And can you see that the gas in container is expanding to container B? So that means there is expansion and no heat can transfer. So the process which involves no heat transfer is known as adiabatic process. The statement of the question is very large, but the conclusion is depending only on this term, thermally insulated. That means no heat can be transferred, so process is adiabatic. Clear? Okay. Now moving further. First law of thermodynamics. I think you should remember, or you must have remembered this relation. What is first law of thermodynamics? The statement is, for example, this is a thermodynamic system. And it has a piston like this. And there is some gas. Now, what I'm saying, I am giving it some heat. I am heating the system by some external source. I am giving it some heat. Then after getting heat, what will happen? The gas will try to expand. The gas will try to expand. So the piston will move up. Piston will move up. So you can say that whenever you give some heat to the system, there might be some work done. There might be some work done. Another thing that may happen, some part of this heat is transferred to the work done, or the piston is expanded or the moved. But the temperature of the gas will also raise now, or may also raise. Temperature of the system may also raise. But if the temperature of the system is raising, that means the internal energy of the system is changing, is increasing, in fact, I can say. So the heat given to a system can perform two things. One is it can raise the temperature. It can raise the temperature and it can perform some work done. So what is the conclusion of first law of thermodynamics? That heat given to a system can perform two things. One is it can change the temperature and it can perform some work. So this is the first law of thermodynamics, statement of first law of thermodynamics. Heat given to a system is equals to delta U plus delta W. Or you can say W. W is what? Work done. So I will mention few things here. Q is what? Heat given or rejected by the system. Now someone might say that you have explained that heat is given. There might be a situation, listen to me, if you compress this system like this is a system and you compress this system, you are compressing it in the downward direction. Then if you compress a system, then temperature of the gas will increase and some heat may be rejected. So what is Q? Heat given or heat rejected by the system. What is delta U? Is the change in internal energy. Change in internal energy. W is the work done. Clear? Everything is clear. On which principle this law is based? This law is based on nothing but conservation of energy. This law is based on conservation of energy. You can write it on your notebook if you have, or you must have a notebook, that this law is based on conservation of energy. Moving further. Now, there is a sign convention that when you should take Q positive, when you should take Q negative, take the screenshot of this. What it says, heat given to a system is positive. Heat rejected by a system is negative. This is a sign convention. Work done by the system, that means in expansion, work done is positive. In compression, work done is negative. That I have told you already. Now, if temperature is increasing, that means delta U is positive. If temperature decreases, then delta U is negative. The process, the analogy by which you can remember this, it's up to you. But you should remember all these things. That's a mandatory thing. Mandatory thing. Clear? Okay. So we will move further. Okay, so there is again a previous year question on your screen. The question is, read it out. Okay, one thing that I have noticed that you guys are not interested in the question paper solving. You guys are just listen. The amount of theory you are studying is not important. The amount of practice you are doing is important. In this crash course, what we are doing, we are discussing some theories, some formulas, and some PYQs. Some PYQs, not a large number of PYQs. So what's more important for you is to solve the question papers that are being held, जो हम लोग conduct कर रहे हैं या फिर जो PYQs हैं, you should do those questions. Without them, it's wastage of time. The theory amount of theory you are doing is important, but the question practice is most important that you are missing. So I will suggest you to go with the question because type of question is same every year, nearly the same, you can say. So if you practice last 2-3 years questions, then it will be beneficial for you. Try solving the questions of the chapters that you have studied. Start with that. You have only 1 month time, I think the April is there. So you should start practicing. Otherwise, it's a wastage of time. Okay. So the question says, an ideal gas is taken from A to C. A to C via 3 different paths. ABC, AC, and ADC. Okay, listen to me. This is our initial point A. This is our final point C. Clear? Now, process is going from either ABC or AC or ADC. Yani 3 paths are there to reach C from A. Again, the next statement says the internal energies of gas at A and C are P naught V naught and 5 P naught V naught. That means at A, internal energy is what? P naught V naught. And at C, internal energy is 5 P naught V naught. This is given in the question. Clear? Okay. The total heat supplied during the process ABC and ADC respectively. Okay. So they are asking the total heat supplied during the process ABC and ADC. Don't worry, the question might look like a very lengthy question, but it's a very simple question. Listen to me. Can you see that this is a cyclic process? If I talk about complete process, now you can see that delta U for A to C. If I talk about delta U is what? U final minus U initial. Final point is C, initial point is A. So the delta U is going to be delta U is equals to put internal energy at C is what? 5 P naught V naught minus P naught V naught. That is 4 P naught V naught. This is delta U. Okay. Now, moving further. Now, what we are interested in heat supplied during the process ABC. So first of all, identify the process ABC. I have mentioned the process ABC. Look at this process. Clear? Now, what we know that heat supplied is asked, that means they are asking about Q. And for Q, there is only one relation. Q is equals to delta U plus W. This is what first law of thermodynamics. Now, if I solve, Q is to be asked, delta U is what we have calculated 4 P naught V naught plus work done. Now you need to calculate the work done in the process A, B, C. How many of you can identify that what is process AB? What is the name of the process AB? Can you identify? What is the name of the process AB? Just answer me. I want to see some answer on YouTube and Zoom as well. What is the name of the process AB? Anyone? Work done in isobaric process. Very good. Very good. Okay. Setu Lakshmi. Very good. So in isobaric process, AB is isobaric and BC is what? Isoporic. You can see that. BC is what? Isoporic. So you can see that that is work done in process AB plus work done in process BC. That's what is the total work done. Now again, if I write, it will become Q is equals to 4 P naught V naught plus work done in the isobaric process is what? P delta V. So pressure at this complete process is given as 2 P naught. So that is 2 P naught. And change in volume from A to B. This is V naught. Initial, final is 2 V naught. So what is the change in volume is V naught. Plus work done in BC process. BC is isoporic. So work done is 0. So if you solve that, Q will be 4 and 2, 6 P naught V naught. Q is what? 6 P naught V naught. That means for process ABC, work done is 6 P naught V naught. So after solving only one part, we can say that answer is going to be C. Because only 6 P naught V naught is mentioned here. And all other options do not have this option. Very good. 2 P naught and V naught. Very good. Okay, so I think this point is clear. Now, if you solve about, okay, what's this? If you solve for process ADC, process ADC, again you will write, or can I leave it to you that you can solve it? That again delta U plus delta W, delta U is again 4 P naught V naught plus work done. If you talk about ADC, the process involves work done in AD plus DC. Work done in AD is 0 plus work done in DC process is what? Pressure here is P naught. Volume change is V naught. So that is 5 P naught V naught. So which option is correct? Option C is correct. Is this question clear to you? Only then we will move further. Heat engines. Very good. Okay. So what is this? What is heat engine? Heat engine is a kind of device. Is a kind of device which converts heat into work done. Converts heat energy into work. Clear? The statement is clear. Now, what is the construction of what is the schematic thing of the heat engines? What is this? The heat engine has two important things. One is there is a high temperature source. There is a low temperature source. High temperature is known as source and low temperature is known as sink. Sink is generally the thing where we throw out the things. So what happens? Heat engine or the working substance takes heat from the high temperature body, converts it into work done, and rejects the remaining heat to the sink. Listen to me. It takes heat from high temperature, converts it into work done, and remaining heat is rejected to the sink. Clear? So the work done, you should remember what will be the work done is Q1 minus Q2. Q1 is the amount of heat taken from the source. Q2 is the amount of heat given to the sink. And work done is Q1 minus Q2. Clear? Okay. Another thing, the most important thing, what is the efficiency of heat engines? Efficiency of heat engines is represented by eta, and it is given as 1 minus Q2 by Q1. 1 minus Q2 by Q1. You should remember here what is Q2? Heat rejected to sink. And what is Q1? Heat taken from source. If you can remember this relation, then it's very important. If they talk about percentage efficiency, then you should multiply it with 100. You should multiply it with 100. I think clear till now. Moving further. What is second law of thermodynamics? First law of thermodynamics, you remember. Now we are talking about second law of thermodynamics. This is again a very important thing. There are two statements. One is Kelvin-Planck, another is Clausius statement. Remember those relations. They are very important. The statement of Kelvin-Planck says, it is impossible to construct a heat engine whose efficiency is 100%. Efficiency is 100% means it can convert all the heat taken from the source into work done, and nothing is rejected to the sink. So this is the statement of Kelvin-Planck statement, that it is impossible that a heat engine converts all of the heat into work done. At least some of the heat is to be rejected. Otherwise, it will not work. Clear? Second statement is Clausius statement. What it says, this is again a very important relation. It is impossible for a device to transfer heat from a colder body to a hotter body without any external work. The thing you can see that generally what happens if there are two bodies like this. If there are two bodies, this is at 100 degrees Celsius and this is at 50 degrees Celsius. If you connect both of them, then you can say heat will transfer from high temperature to low temperature. That's for sure. The statement says you cannot transfer heat from low temperature to high temperature. That's obvious, you cannot transfer, but it can be transferred by an external work. If some external work is there, then you can transfer heat from colder body to a hotter body. That's what our refrigerator do. The temperature inside the refrigerator is colder than the surrounding, but still it transfers heat from the inside to the outside. You can see that now. What is our refrigerator that you see in the fridge, or you whatever you call it, refrigerator, I think it transfers heat from a colder body to higher body. And for that, there is a device which performs work done, that is generally you call it as compressor. I think that you might have called it as compressor. So I think till now everything is clear. Two statements now. What is a Carnot engine? Carnot engine is an ideal engine. Carnot engine is an ideal engine which operates in a reversible cyclic process. Which operates in a reversible cyclic process. Okay. This one now you are asking? Should I explain it or? Okay, sure. Okay. So it operates in reversible cyclic process. That's clear. Now, the cyclic process of Carnot engine is this one. Remember this. I have mentioned everything here. This is a reversible cyclic process. Like cyclic process is what it starts from A. This is initial point. and go to B, C, D, and returns to A. So this is a cyclic process. You can see that. And what is the meaning of reversible process? Reversible process means like that. I will explain you the reversible process on this slide. Let's suppose this is a PV diagram. PV diagram. And a process takes place from A to B. A to B like this. And this is, you can say, expansion. This is the expansion. You can see that. Now, what if I start compressing the system again? What if I start compressing the system again? Then if it follows the same path, then it is known as reversible process. What I'm saying, a process starts at A and is expanded up to B. Now, if I reverse the process, if I compress it again, then if it follows the same path on the PV curve, then the process is known as reversible process. Generally, processes are not reversible. Some heat is, some form of energy is lost during the process. Okay. So what is this? A to B is the process of isothermal expansion. And in this process, system takes a heat Q1. When the gas is isothermally expanded, it receives heat from the surrounding or from the source, that is Q1. So Q1 heat is given by the source. So it has taken some, I have mentioned a wrong spelling here, SOURCE. Okay. From source, it has taken some heat Q1. During the BC, this is adiabatic expansion, so no heat is taken or rejected. Again, C to D, it is again a isothermal compression, and in this process, it rejects some heat like Q2 to the sink. To the sink. Okay. Again, D to A, there is a adiabatic compression. So the cycles you can remember, one is isothermal expansion, one is adiabatic expansion, and two are compressions. Clear? Now moving further. Efficiency of a Carnot engine is what? Eta is equals to 1 minus T2 by T1. 1 minus T2 by T1. This is very important. Carnot engine is very important for your examination. T1 is the temperature of the source. T2 is the temperature of the sink. How you can identify the temperature of source and sink? Source temperature is high. This is, you can say, high temperature. And this is, you can say, low temperature. Always. This is the thing. Clear? In a question, whenever you see a high temperature and then two temperatures are there, some question might be there like this. The question might be calculate efficiency of a Carnot engine which operates between 0 degrees Celsius and 100 degrees Celsius. So can you identify which is source and which is sink? Which is T2 and which is T1? The temperature which is high is T1. The temperature which is low is T2. Clear? Moving further. There is a concept question. An engine has an efficiency of 1 by 6. Okay. When the temperature of the sink is reduced by 62 degrees Celsius, its efficiency is doubled. Temperature of the source is. Okay. Listen. There is one more question after that. Okay, heat pump is also there. And there is okay, so time is very less. Let's solve it. An engine has an efficiency 1 by 6. So what is the relation for efficiency? Efficiency is equals to 1 minus T2 by T1. Okay, what you can see that Efficiency is given as 1 by 6. That means 1 by 6 is equals to 1 minus T2 by T1. So can you see that T2 by T1 will be 1 minus 1 by 6, or T2 by T1 we can write it here. T2 by T1 is 5 by 6. Let it be equation number 1. Now, in the next statement, it says temperature of the sink is reduced by 62 degree. Now, if I change the color of the pen, then what it will be? Again, efficiency will become double. So now new efficiency, if you double the efficiency of 1 by 6, again, if I write eta is equals to 1 minus T2 dash by T1, eta dash. Can you justify this thing? Because temperature of the sink is reduced, but the temperature of the source is same. So you can write it as eta dash originally was 1 by 6, and if you double it, it will become 2 by 6. This is not the square thing, it's a multiply, is equals to 1 minus, you can say temperature was reduced by 62 degree, that is T2 minus 62 divided by T1. That you can see T2 minus 62 by T1 is equals to 1 minus 1 by 3. You can divide it 2 and 3. So it will become 1 minus 1 by 3. Or you can say that T2 minus 62 by T1 is equals to 2 by 3. This is equation number 2. How many unknowns are there? 2 unknowns are there, T1 and T2. How many equations we have formed? 2 equations we have formed. So if you can solve these 2 equations, then we will get our answer. We will get our answer. Is it clear? Solving thing is up to you. You can solve these 2 equations and you will get the answer. This is the simplest thing. Moving further. You will get the answer as C. This is 99 degrees Celsius. You will get after solving. Make sure. Now, what is heat pump? This is our last topic that we are going to discuss. Heat pump or refrigerator, what? This is the reverse of heat engine. Reverse of heat engine means in heat engine, it takes heat from the source. Now what happens? It takes heat from a low temperature body and give it back to the high temperature body. The flow is there. And for this, you have to perform some work. Some external work is needed. You can see all the arrows are reversed in the heat pump. What happens here? It takes some heat from low temperature, give it to the high temperature, and for that, as per the Clausius statement, some external work is needed. So what will be the important formula for this? The important thing is that what is coefficient of performance that is being asked. What is the coefficient of performance for the heat engine, for the heat pump or refrigerator? The formula is this: T2 over T1 minus T2. T2 over T1 minus T2. Is it clear? Now, there is one more question that we can solve. You can solve it as your homework. This is a very simple question. This is a cyclic process. Okay, one more thing to be remembered by you. One more thing that I will explain to you. Listen, 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 listen. I am not solving the question. I am giving you some pro tip. Or I will go where I should. Okay. Here you should listen. There are a lot of things that we have studied. Now listen. Work done in this cyclic process. One thing, important thing to be remembered by you. This is again a punchline that you should remember. if there is a cyclic process, it might be in the clockwise direction or might be in the anti-clockwise direction. Two situations might be there. There is one cyclic process like this. This is anti-clockwise. And this process, you can see this is clockwise. You can see on your screen. So what is the thing for cyclic process? This is again a very important thing. Work done will be positive if process is clockwise, and work done will be negative if process is anti-clockwise. The only thing that will create confusion is the sign of the work done, because all the 10 students make a mistake, because there were four options, two were of positive signs, two were of negative signs with the same magnitude. Then how will you identify is the important thing to remember this for cyclic process. That means in this process, work done will be positive, and in this process, work done will be negative. Clear? I think everything is clear, so we can end this session. I hope the few important things are clear to you in this chapter. Make sure to come and join the next session. Till then, bye everyone. Bye bye.